So here I want to talk about the meaning of T, the power in the time mnemonic formula. So I want to use this example to show you clearly what I'm talking about. So this example I'm using here is question number 5 uh, in the homework 2. So before I talk about this question, why don't I first write down the formula? We know that the future value of a single cash flow at time t is the present value, which is the amount of that single cash flow, times 1 plus interest rate r raised to the power of t. So what I want to stress here is that we have two t, if you notice. One is the subscript, which I circled with the red pen, and the second one is this power t, which I circled with the blue pen. So the first t, the red t, that's just the year number or the period number for the future date. So if the future date, the future year is year 9, year 10, then that's what this t here means. But the second t, based on our end of the year convention, that's the same as the year number. And that's what I said in class, that the reason we use the end of the year convention is because we can write this formula very conveniently. But we have to be very careful, because sometimes the year when you receive the cash flow may not be the true current year or year 0. So the second T here actually stands for the number of periods, and if it's annually compounding, then it's the number of years between the year when you receive the cash flow and the year for the future date. So now let's get back to this question to show what I mean exactly. So let me first read the setup. You are scheduled to receive $19,500 in 2 years. When you receive it, you will invest it for 6 more years at 8.0% per year. How much will you have in 8 years? So let me draw a chart just to make sure we understand the setup. I think that's very, very important. Actually, the biggest hurdle to solve the finance question, especially the time mnemonic questions, is how to use the right framework to analyze the question and how to put the numbers in the right place. That's the most important part, and also turns out to be the biggest hurdle to solve the questions. So let me draw a chart. Basically, we need 8 years. I believe the setup says we have 8 years. 3, 4, 5, 6, 7. Wow, exact. Good. So let's go back to the setup. It says that you are scheduled to receive $19,500 in 2 years. So that means the cash flow takes place here, year 2. And the amount is 19,500. And it further says when you receive it, you will invest it for 6 more years. So that's why we have year 8, because that's basically investing for 6 more years. So it's asking you what's the future value basically, right? How much will you have in 8 years? So that's the future value. The future value at year 8. So that's basically what this question is asking. So let's write down all the numbers we know. We know that present value, what's the present value? Yeah, actually you can see we can use the formula in a very flexible way. So in general, present value should be the true present, right? By true present, I mean here. But in this case, we don't have any cash flow here. So the true present doesn't exist. I mean, it exists, but we don't have any cash flow there, so it doesn't help us to solve this question. So what we can do is that we can move to year 2. So when we stand at year 2, then year 2 becomes our present moment. And then we can stand at year 2 and look forward. So then you can probably you can better understand why we say the t, the second power, the t, the power here, the t here in the power, that's not necessarily the year number. Because when you stand at year 2 and look forward, there are only how many years? 8 minus 2, which is 6 years to go to reach the year 8. So that means the power here should be the number of years between your the year when you receive the cash flow and the future date. So in this case, it's 8 minus 2, which is 6. Okay, so by pretending we stand at year 2, then the present value is 19,500. And the interest rate, what's the interest rate? It's 8.0%. So it's 8%. And what's that t in the power? As we said, that should be equal to 8 minus 2, which is the difference between the year when you receive the cash flow and the future date. That's 6 years. So now I can plug in the formula. Okay, need more space. So when I plug in the formula, this should be future value at year 8 equals present value 19,500 times 1 plus interest rate raised to the power of 6. Go back. That's pretty much what we wrote down there. So now I need a calculator. So let's put the numbers into the calculator. So it's 19,500 times left parentheses 1 plus 8. I don't have a percentage sign, so I need to divide it by, oh, too quick. 100, right parentheses, and then I need a power function. Here, this sort of looking like a triangle sign, that's my power function. So power raised to the power of, as we said, should be 6, right? Okay. So the final answer is a 30,944.05. So if you go back to the instruction, it asks you to keep two decimal places, and that's why I kept two decimal places. So now let me put this number back to the connect and see whether we got the right answer. 3944. Oh, 3944.05. So check my work. Yes, we got it right. So again, what I want to discuss, stress here is that in the formula, basically I just use this example to show you that in the formula, the power here stands for the number of years or number of periods if it's non-annual compounding interest rate between the year when you receive or when you receive the cash flow and the future date. All right, so that's it for this discussion.